First Swede to receive the Nobel Prize. His name is Svante Arrhenius. At the end of the 1800s, Svante is living in a world which is undergoing many major changes. Advancements in technology and scientific discoveries are plenty. Train and the telegraph are now in use, making it faster than ever for both people and news to travel. Electricity is now providing new opportunities for the whole world and fascinates Svante Arrhenius, which leads to his groundbreaking ideas of pushing the boundaries in the relationship between chemistry and physics. Today we know much more than we did during Svante Arrhenius' time. Such things as that everything around us, computers, people, and even air, is made up of atoms. There are over 100 different types of atoms, such as carbon, oxygen, and hydrogen. They are called elements. They can be combined in many different ways to become new substances. One example is the 2 hydrogen atoms and 1 oxygen atom, which form water. This is known as a chemical compound or molecule. Svante Arrhenius wants to find out what happens when 2 compounds are mixed, like water and salt. How does the blending of these compounds change them? To understand this, he enlists the help of the new discovery, electricity. Completely pure water, H2O, is a chemical compound that does not conduct electrical current. Same applies to common table salt, NaCl, consisting of 2 kinds of atoms, sodium and chlorine. Neither of the 2 chemical compounds are conductive. But when you mix them, suddenly the new mixture carries current. How is this possible? At the time when Arrhenius begins his investigation, it was believed that electricity itself was responsible for changes in materials. Svante Arrhenius has a new theory. He believes that something happens to the very structure of the material when they bind with each other. Today we know that it is the bond between the atoms of salt which change. Atoms consist of a positively charged nucleus, around which spin negatively charged electrons. Some sodium atoms gladly give away an electron, resulting in them having a positive charge. Other atoms, like chlorine, readily take up an extra electron and become negatively charged. Charged atoms like these are called ions. And separately, as free ions, they are able to carry current. But negative and positive ions like to pair together into crystals, such as salt crystals. And these do not carry electricity. However, when you dissolve salt crystals in water, something happens. The ions let go of one another and are now free ions again, and thus once again conduct electricity. Svante Arrhenius couples together electricity, which really belongs to the field of physics, together with his interests in chemical reactions, belonging to the field of chemistry. His theory is met with opposition, and as a result he leaves the University of Uppsala and moves away from Sweden. After a few years abroad, he is invited back to continue his controversial research here at the University of Stockholm. Even though he didn't know exactly what the atoms looked like, Svante Arrhenius' experiments were successful in illustrating the principles behind chemical compounds, how these compounds could change and take on completely new properties, something that today facilitates the foundation of research in such things as medicine and climate change. Despite the early harsh criticism he received from many of his colleagues, in the end, it was a successful achievement. And for his discovery, Svante Arrhenius was the first Swedish scientist to receive the Nobel Prize in chemistry in 1903.